Hello guys, let's start today's topic that's very important, how to decide order of basic strength. So as we know, the basic strength of any compound is its power to donate lone pair electrons. So how can we decide the basic strength? There are some factors on which the basic strength is depend. For example, first factor is state of hybridization and basic strength. We are taking an example. Suppose in compound 1 there is NH2, that NH2 is actually sp3 hybridization. sp3. In compound B the nitrogen atom have sp2 hybridization, sp2. So in compound A nitrogen is sp3 hybridized, and in compound B nitrogen is sp2 hybridized. We know as the s character is increased, if percentage of s character is increased, then electronegativity is also increased. So electronegativity also increase. In sp3 hybridization, the percentage S character is 25%. In sp2 hybridization, the percentage of S character is 33.33%. So we can say the B compound, the S character in nitrogen atom is more than A. That's why the nitrogen atom of B have more electronegativity than A. So if this nitrogen atom of B have more electronegative, so it don't want to donate its electron comparatively to A. So A can easily donate its electron comparatively to B. That's why A is more basic and B is less basic. So what is the base? Base is the compound which can donate easily its electron. So basicity depend on mainly on two factors. First, how much easily the compound is donating its electron, as well as the electron density on the atom. If electron density is increased, so we can say the basicity also increased. And if any atom donate its electron easily, so it means it is a good base. Now come on second factor. The second factor is carbon chain length and basic strength. If carbon chain length is increased, for example in this compound, so plus I effect is also increased. So plus I effect of first compound is more than the second compound. That's why due to its plus I effect, the carbon chain or alkyl group increase the electron density on nitrogen atom. So in first compound, electron density on nitrogen atom will be more because it is a 3 carbon chain. It have more plus I effect. That's why this compound is more basic. Next is the central atom and basic strength. Let's see. We have two compound. In first compound, the central atom is carbon, and in second compound, the central atom is silicon. As we know, the silicon is more electron positive. Silicon is more electron positive. That's why it it push the electron towards nitrogen atom more easily. That's why electron density in this case is more on an atom. That's why this compound is more basic. Next factor is extent of inductive effect. Let's see, we are taking another example. Suppose in this compound there is CCl3 which is attached to alpha carbon. but here CCl3 attached to beta carbon. Now what happened? Actually, we know that CCl3, if CCl3 is there, it will show its minus I effect. Minus I effect. That's why due to minus I effect, it decrease the electron density on nitrogen atom. And we all know the inductive effect is distance dependent effect. That's why in second compound, in B compound, CCl3 at beta position, it's far from NH2, lone pair of NH2. That's why impact of inductive effect in B compound will be less. That's why the compound B can easily donate its lone pair compared to A. That's why the compound B, this compound, is more basic compared to A. Next is basic strength and inductive effect. As we know, CF3 and CCl3 both have minus I effect, minus I. But actually fluorine is more electronegative. That's why CF3 have minus I effect more than CCl3, and due to its minus I effect, it decrease the electron density on nitrogen atom. That's why it decrease the basic strength. So CF3 decrease the basic strength more because its minus I effect is more. So this compound is less basic, and this compound, the CCl3, this compound is more basic. So as we go downward, the basic strength is increasing. Next one is delocalization of lone pair and basic strength. Another example is that in first compound, the lone pair of nitrogen atom are in conjugation with this benzene ring. There is pi lone pair conjugation. That's why due to conjugation, this NH2 group cannot donate its electron to acid easily. And in compound B, these lone pair are not delocalized. They are actually localized lone pair, localized. So these lone pair, compound B cyclohexylamine lone pair, can be donated easily. That's why cyclohexylamine is more basic. More basic. So if lone pair comes in conjugation, they cannot donate easily to acid. That's why these type of compound are less basic. Next is delocalization of negative charge and basic strength. Let's see. Same case is here. There is NH2. These lone pair are in conjugation with this carbonyl group. These lone pair in second compound, lone pair benzamide lone pair are also in conjugation with carbonyl compound, but actually this carbonyl group is in conjugation with benzene ring. That's why these lone pair are not so much extent of these lone pair are not much in conjugation with carbonyl compound, because this carbonyl compound is playing double role. Double role means it is in conjugation with benzene ring as well as in with lone pair. That's why. And the second reason is that this benzene ring have minus I effect. That's why it, we can say it decrease the basic strength. So we can say benzamide is, yes, benzamide is obviously more basic than acetamide. Next one is basic strength of pyridine and pyrrole. The lone pair of pyridine, actually the lone pair of pyridine are present in sp2 hybridized orbital. That's why they cannot participate in conjugation. with d orbital of carbon, cannot make pi bond with d orbital of carbon. That's why they are actually localized electron, localized. So we can say in pyridine, lone pair are not in conjugation. Actually, in pyridine, pi-pi conjugation is present. So lone pair are localized electron. Lone pair are not delocalized. But in the case of pyrrole, the lone pair are present in unhybridized, unhybridized p orbital. The plane of unhybridized p orbital is similar with the plane of carbon p orbital, which is making pi bond. That's why the lone pair of pyrrole can easily make pi bond with carbon p orbital because their plane is same. So we can say the lone pair of pyrrole are in conjugation with the pi bond. That's why we can say the lone pair of pyrrole is not easily available. So pyrrole is less basic, but the lone pair of pyridine are easily available. That's why pyridine is more basic. Let's see another example. The example is that basic strength of guanidine and imine. We know guanidine actually is the strongest organic nitrogen base. It's very important. Guanidine is strongest organic nitrogen base because when this nitrogen atom donate its electron to H plus ion, it will convert into NH2, C, NH2, positive charge and NH2. Now this positive charge can delocalize on these three nitrogen atom. First, second and this third. So this positive charge can delocalize in three nitrogen atom. That's why we can say it is very stable. So guanidine is the strongest organic nitrogen base. So it is more basic than isopropyl group. Next one is that Bradit's rule and basic strength. It's also very important that what is a Bradit's rule? Bradit rule is that bridgehead carbons cannot be sp2 hybridized. Bridgehead carbon cannot be sp2 hybridized. Cannot be sp2 hybridized. So lone pair of compound A can be, we can say, they can delocalize. They can delocalize because there is lone pair pi bond conjugation. So because they can delocalize, so are not easily available. So it is less basic, but we cannot delocalize the lone pair of compound B, nitrogen atom of compound B with this oxygen pi bond. Why? What is the reason behind that? The reason is that if we do such, then actually we are breaking the Bradit's rule. We should make like that O negative. So this compound is not possible because in this case the bridgehead atom is sp2 hybridized, which is not possible due to steric strain. So it will, we can say, if we are doing like that, so it will violate the Bradit's rule, which is not possible. So we can say the lone pair present on nitrogen atom of second compound are localized electrons, so they can donate easily. That's why the compound B is more basic. Then mesomeric effect and basic strength. Yes, it's very important factor which affect the basic strength. Like CH3O, it show plus M effect or plus R effect. But NO2, it is electron withdrawing group. deactivating group, so it will show minus M effect. Due to plus M effect, CH3O donate its electron which participate in conjugation, hence increase the electron density on nitrogen atom. But NO2 withdraw the electron, that's why it decrease the electron density on nitrogen atom. So we can say the compound A, first compound, is more basic than B. Then steric inhibition of resonance, that is SIR, steric inhibition of resonance and basic strength. We are taking two example. This is the compound A and that is the compound B. In compound A, lone pair are present on an atom. In compound B, the lone pair are present on an atom. Actually, in the compound A, these lone pair are in conjugation with benzene ring. But due to in compound B, there is very we can say a large steric hindrance creating by these two CH3 group. That's why the plane of this nitrogen atom will change. So if plane of this nitrogen atom will change, that's why this lone pair cannot participate. Lone pair of B nitrogen atom cannot participate in conjugation because due to steric hindrance, the nitrogen atom plane will be changed. So that's why we can say in compound B, nitrogen atom lone pair can be easily donated. So compound B is more basic due to steric inhibition of resonance. Next is that base and basic strength. Let's see ortho effect. That's very important effect, ortho effect. If any group is present on ortho to NH2 group in benzene amine or aniline, then it will decrease the basic strength. Why? Because due to steric hindrance, this NH2 group cannot donate its electron easily. So that's why it will create, CH3 group is actually creating steric hindrance when it is present at ortho position. So we can say it will decrease the basic strength. So it is more basic. Compound A, that one is A and that one is B. Compound A is more basic. Let's see next one. Thanks.